Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is magic triplets. So, hi Rishit, hi Rakesh, hi Atrey. So, give me a quick +1 in the chat if I'm visible as well as equally audible. So, let us start. Okay. Okay, so in this one, you are given an array. I would tell you how this is. Okay, we already have this opened up. Yeah. So in this one, we are given an array. Okay. So suppose this is the array A, and this is like 1, 3, 5, 2. Okay. So let me just say this. Yes, 1, 3, 5, 2. Next, we move forward and we ask that we need to find three index where I should be less than j and j should be less than k. And it should be like this, that a of I should be less than a of j and it should be less than a of k itself. Okay, so you are given an array, you need to find three indexes such that the numbers are like this. So you need to find out how many of them satisfy this condition. Okay, you need to basically count it. Okay, so एक array दिया गया है, we need to report three indices such that I is the smallest, j उसके बीच में है and k is the largest one. Okay, and a of I is like this. So now, what is the first intuition to solve this, or the brute force approach to solve this? The first brute force approach is that try every possible way. Okay, we would try every possible way. Now, how we can try every possible way? We can try every possible way by simply writing a for I loop, then a for j loop, and then a for k loop, where I would go from 0 till the value n. Okay, j would also go from 0 till the value n, and k would also go from 0 till the value n. And you can write it that if I is less than j, j is less than k, then it should be sufficient enough. Okay, so if these two conditions are fulfilled, we would have C plus plus and it would solve the purpose. Okay, so basically you would count and you would return. So what is the time complexity of the solution? The time complexity of the solution, the first loop, the last loop is doing an operation, and this loop is doing an operation. Okay, this is doing an operation, and in each operation it is doing an operation by this k loop. So this is n square operation. So this loop is running, so n operation where each operation is equal to n square. So n one operation, so I can say that this total is doing n square operation. Okay, n square operation, and this is doing n operation. So I can say that one operation of the I loop is equal to n square operation. So multiplying n on both side would be nothing but n cube operation itself. Okay, fair enough. Do I make sense? Give me a quick one in the chat. Give me a quick one if I'm clear till this point. Hi Nakaj, how are you? What is giving time complexity? NQ. Okay, so now let us move forward. Okay, so now we have n cube time complexity. Now we are told this thing. Okay, let me just take the screenshot of this. This is absolutely very important. Okay, okay. So now in Geeks for Geeks platform, we do have a mention of expected time complexity. But suppose this was not given and you are given this in an online judge. Okay, so you need to know if this approach would pass or not. So the maximum length of an array, n is the length here. So maximum length of the array is 10 to the power 5. Okay, so 10 to the power 5 to the power 3 is operation would be done. That is 10 to the power 9 operation would be done in total, which is definitely greater than 10 to the power 8. So you would be getting a time limit exceeded. Okay, so this approach would definitely fail. Okay, so we need to think of a better approach if we want to get an AC, and it is already told and expected here also. Like we need an approach of big O of n square. So now we are told, okay, that we are told to find I is less than j is less than k. Okay, fair enough. And then we are told that we need to have a of I less than a of j and is less than a of k. And the very first we can think of is that we would fix this k, we would fix this k and we would count how many I and j are there. But the problem would lie to find the value of I and j. The first thing that would come into our mind is having the sum less than a of k. Having the sum less than a of k by I and j, I and j, I and j is nothing but two pointers. So the first approach is that we would get two pointer. Okay, two pointer approach to find the number of values that is less than a of k. Okay, so that is also not feasible. Why? Because the array is unsorted. The array can be an unsorted array. It is not mentioned that the array is sorted itself. Okay, it is not mentioned here. So the array can be unsorted. So what is the two pointer approach? Suppose we have 1, 2, 3, 4, 5. Suppose I want the value of 6. So how we would do it? We would have a pointer here, we would have a pointer here. This is equal to 6. Okay, let's not have this, let's have this. Yes. So suppose this is equal to 6 and we want the sum as 6. Suppose we want the sum as 6. How do we use two pointers? So this value is 5. This value is 5 and we want to increase the value because the value we need is 6. So if we want to increase the value, we would increase this pointer because we know that the array is sorted. So if we move ahead this left side pointer, the value would increase. If we move the right hand side pointer towards the left hand side, then the value would decrease. This is how we would find it. But this works on only sorted array, so this is also discarded. Okay, so the first intuition can be that we can think of two pointers, but two pointers is not a value here because it works on only sorted array. So now what can we think of if we move forward? The next thing that strikes in our mind is that we can have something kind of sliding window, but we don't really know that how many numbers would be between a of ij and a of k. Okay, so variable window size is nothing but two pointers. Two pointers is not running. Neither sliding window would work because the size of the window is not specified. Okay, it is just told that it should I should be less than j. So I can be 0 and j can be 100 also. I can be 0 and z can be 1000 also. Can be. So the length of the window is not fixed. So sliding window and two pointer is discarded now. So we can't fix the last one. If we can't fix the last one, let us move and try to see any other way we can solve this. Okay. So now we would try to find this. So trying to find this is more easy. Okay. Trying to find this is more easier. Why? because we would fix a ith pointer here, jth pointer here, because this is the middle one, and we would run a loop from 0 till the value of j minus 1. Okay, and we would go for j plus 1 till the value n minus 1, and this would account for I, and this would account for k. So this is just like, let me visualize it again. So suppose we tried to fix the last one, that is not feasible, but we can see that if we fix the middle one, then there are properly three segments that needs to be catered. Okay, the three segments are, the first value is nothing but 0. This value is j, which is fixed, and this value is n minus 1. We know this or not? So if this is j is fixed, then this value would be j minus 1, this value would be j plus 1. We have this or not? So if you see this properly, we can find the value of I by this one, and we can find the value of k by this one. Okay, I, j is fixed, and k. So this is the left side. So on the left hand side, we need to find values less than j, and on the right hand side, we need to find the values greater than a of j. So this is greater than a of j, and this is less than a of j. Okay, like a of j should be greater than a of I. Okay, fair enough. This can be done or not? Okay, so yes, so if we fix j, then the other two loop are doing n minus 1 work. So for fixing one index, we are doing n minus 1 operation. So for fixing n index, we would be doing n minus 1 multiplied by n, which is equals to n square minus n. Okay, the upper bound is n square, so that is why the time complexity would be n square. So this is not even n square because the constants are ignored, so n into n is equals to n square from here only. Okay, so time complexity n is n square. So now let us see, we have seen that the value of n can be at most be 10 to the power 3. So 10 to the power 3 to the power 2 is equals to 10 to the power 6, which is less than 10 to the power 8. So we would definitely get an AC if we are able to implement this correctly. Okay, so the intuition of fixing first the k, then realizing that two pointer can't be there, sliding window can't be there, so we can't really fix the last one. So next, if the last one can't be fixed, we come to the middle one. Can we fix the middle one or not? Yes, we can fix the middle one. How? Because if the middle one is fixed, then the job is just to find larger elements than a of j on the right hand side and smaller elements on the left hand side. We need to find this. Now there is something more to it. Okay, so this was the intuition to come to the solution. Okay, so now this is the solution, but there is something more to it. What is this more? Okay, so now if you see that, suppose this is a of j. Now we have a of k, we have a of k plus 1, and we have a of k plus 2, and here we have a of I. Okay, and then we have a of I minus 1, we have a of I minus 2, and we have a of I minus 3. We know this, and we know this fact that a of I is less than a of j, and this is less than a of k. We know this thing is true, matlab a of I छोटा है a of j. So then these all would also be true. These all would also be true or not? Because ये वैल्यू सबसे छोटा है और ये और छोटा हो जा रहा है, तो this is true. ये वैल्यू सबसे बड़ा है, ये और बड़ा हो जा रहा है, this is also true. This value is the smallest and it is getting smaller. So this the equation would remain true. Okay, like if this equation is true, then this equation is also true. Okay, this equation is also true. So now we can see that this can make pair with these three. Okay, this can make pair with these three. This can make pair with again these three with a of j between them, like a of I minus 1, a of j, and a of k plus 1. If this is also true, okay, and this can make pair with this, like this can make pair or not? Yes, this can make pair. Okay. So similarly, so what we can say is if there are L values here, if there are L values here and there are R values here, the number of pairs that can be made is L into R by this. Like these all would be able to make pair like this. Okay, like from this to this, then from this to this, then this. Okay, like this it can make pair or not? Yes, it can make pair. Okay, like a of j, I is less than j, and a of k. So we need to find, so suppose the number of values satisfying this condition, the number of values satisfying this condition is L, and satisfying this condition is R, then we would add answer plus equals to L multiplied by R, and this would be done. Okay, so now let us move to the coding part and we would see how this can be coded. So am I clear with the intuition to the solution? And then we would talk about this. So am I clear with the intuition or not? Give me a quick yes or no. Hi Kartikeya. Hi Amar. Okay, and so we put there then not running. Can we found lesson number then when? Hello, is something can hear me? I am Rohit and I am from. How we would find LNR? So LNR is nothing. So let me just present the screen again. Give me a quick one if this thing is clear. Give me a quick one. Okay. So let us see what is this LNR. So LNR is nothing but number of A of I less than A of J, and R is what? Number of K that is greater than A of J. Okay. And the count of A of I is L. The count of A of K is equal to R. Okay. So this would be more clear when we would move to the implementation. Okay, so I'm more accustomed with the smaller variable names. So I would just rename this to A itself. Okay, and this should be good to go. Okay, so I would rename this with A. So I would first store the size so that I can use it whenever required. Then I would initialize the answer is equals to 0 to store the answer. Then I would start with int j because that would be the middle pointer to it. Okay, so j is equals to 0, j is less than n, and j plus plus. Okay, then we would initialize int l, so left small. Okay, so left small is equals to 0 and right small is equals to 0. Initially the count is 0. So we have fixed a j. So we would start the pointer from 0 till j minus 1. Okay. So we would start the pointer for loop int I is equals to 0, I is less than j, and then I plus plus. Okay. This would be the very first loop. The second loop would be for int j plus 1 till n minus 1. So I can say that int k is equals to j plus 1, and then k is less than n and k plus plus. Okay, so now we would say if a of I is less than a of j. Okay, if a of I is less than a of j, then L plus plus. And if a of k is greater than a of j, then r plus plus. At the end, whatever values we are getting, answer plus equals to L multiplied by r itself. This would be done, and then we would return the value of answer. Simple enough. Left side में small निकालो, right side में बड़ा निकालो. The number of multiplication would be added to the answer, and this would be done. Now let's just compile and run and see how many errors are we making. Okay, seems like we are not making any errors, but still let us see. Okay, so yes, we are able to do this. So now tell me the line number in which you are facing any issue. Okay, so I would just remove this, stop the screen sharing, and now I would present the Chrome tab of this. So now tell me at what line number you have the issue. Okay, tell me, this is the code. Tell me the line number in which you are facing issues. Okay. Okay. So how did you apply for SD internship at Geeks for Geeks? So I applied through the internal hiring at Geeks for Geeks, and I was already associated with them for the last 1.5 years. So I was aware that when they are hiring. Okay. So can you tell me the line number in which you are facing any issue? Tell me the line number. No one has any issue? Okay, so I would be waiting for the next 30 seconds. If I don't get any doubts for the next 30 seconds, I would turn off the session. Okay, so that was it for today. So this question was an easy problem if you are able to take the test cases, if you draw the things in a pen and paper. So it might have been instance that I made a mistake. Same goes. Okay, so that is it. So if you're watching the recording, feel free to like and comment the video so that the reach of this video could be increased. Thank you. Good night, everyone. Most welcome.